So angles are formed when two straight lines meet. So assuming that we have a straight line, that is OA, and then we also have another straight line OB. Now at the point of intersection of these two lines, or at the point where these two lines meet, an angle is formed. And the size of the angle formed can be determined by rotating the line OB about O in the clockwise direction to lie on the line OA. Usually, angles are measured with an instrument called a protractor, and I believe that we all know what a protractor is. Now let's move on and talk about the various types of angles that we have. So the first angle we are going to talk about is what we call the acute angle. An acute angle is an angle whose measure or size is less than 90 degrees. So assuming that we have the line OA and then OB. Now the angle formed between these two lines is an acute angle because this angle is less than 90 degrees. So we say that the angle, this is the symbol for angle, so the angle AOB, which is this angle, is less than 90 degrees. Notice that the two symbols are not the same. This is an angle and then this is the less than sign. So the next type of angle we are going to talk about is the right angle. A right angle is an angle whose measure or whose size is equal to 90 degrees. An angle whose measure or size is equal to 90 degrees. So assuming we have the line OC and then OD, then this angle is a right angle because that is the angle COD. So angle COD is a right angle because its measure or size is equal to 90 degrees. Now let's move on to the third angle, which is the obtuse angle. The obtuse angle. Now for the obtuse angle, it is an angle whose measure or whose size is greater than 90 degrees but less than 180 degrees. So now let's focus on the right angle. Now this angle is 90 degrees. So for the obtuse angle, we are going to pull down this line, that is the line OD, in this direction, that is the anti-clockwise direction, such that it will not lie straight as the line OC. Now in that case, the new angle formed is greater than 90 degrees but less than 180 degrees. So assuming this is the line OE, and then we have another line OF. Now this is an obtuse angle because the angle formed, that is the angle EOF, is greater than 90 degrees and less than 180 degrees. So this angle is an obtuse angle. Now to the next one. So the next one we are going to talk about is the straight angle. The straight angle. Now the straight angle is an angle whose measure or size is equal to 180 degrees. Basically, we say that the angle formed on a straight line is equal to 180 degrees. So the angle, that is angle MON, is a straight angle. So the angle MON is a straight angle and is equal to 180 degrees. So the next type of angle we are going to talk about is the reflex angle. The reflex angle is an angle whose measure or size is greater than 180 degrees but less than 360 degrees. So let's consider the angle, assuming that we have a line OA, and then we also have the line OB. Now at the point of intersection of these two lines, a reflex angle is formed. Now this angle is greater than 180 degrees but less than 360 degrees. Greater than 180 because the line OB does not lie flat as OA, and then less than 360 because the line OB does not lie on the line OA. So this angle is greater than 180 but less than 360 degrees. So we say that the angle AOB is greater than 180 degrees but less than 360 degrees. So this is a reflex angle. So let's move on to what we call adjacent angles. Now two angles are said to be adjacent if they share a common arm, a common vertex, and the non-common arms are on the opposite sides of the common arms. So let's consider these two angles. So we have line OA, line OB, and then line OC. So here we have two angles formed. Now these two angles are adjacent angles because they have a common arm, which is the line OB. So this is the common arm. They have a common vertex, that is O, and the non-common arms, that is the line OC and then OA, lie on the opposite side of the common arm. So this is the non-common arm. This is also the non-common arm. So we say that these two angles, that is the angles AOB and then BOC, they are adjacent angles. Okay, so now let's move on to the next type of angle. That is what we call complementary angles. So complementary angles are two angles that add up to 90 degrees. So let's consider the right angle. So the right angle has a measure of 90 degrees. So assuming this is OA and this is OB, and then we have the line OC. Now here we have two angles formed, and these two angles sum up to 90 degrees. So we say that the angles AOC and BOC are complementary angles. Now to the next one, we call that supplementary angles. So supplementary angles are two angles that add up to 180 degrees. So let's consider the straight angle. The angle on a straight line is 180 degrees. So if we have two angles, adding up to 180 degrees, then they are supplementary angles. Therefore, we say that the angles AOB and BOC are supplementary angles. So angle AOB plus angle BOC is equal to 180 degrees. And here also the angles AOC plus BOC is equal to 90 degrees. Now let's move on to the type of angles we call adjacent supplementary angles. Adjacent supplementary angles. Now these angles are basically like the adjacent angles, and for these type of angles, assuming that we have a straight angle, now we have two angles adding up to 180 degrees. So this is OA, OB, and then OC. Now because they are adjacent supplementary angles, we have this to be the common arm, and then OA and then OC are the non-common arms. And then they have a common vertex. So we call these adjacent supplementary angles. So the angles AOB plus BOC, they sum up to 180 degrees. Away from that, if we have a straight angle and then we have more than two angles adding up to 180, assuming that we have angle A, angle B, and then angle C. Now these three angles ABC adds up to 180 degrees. Now let's move on to angles around a point. So when many lines meet at a point, they form angles around a point, and the sum of these angles are equal to 360 degrees. So assuming that we have three lines meeting at a point, we have this to be angle X, angle Y, and then angle Z. Now the sum of these angles is equal to 360 degrees. So we say that X plus Y plus Z is equal to 360 degrees. So that is that with angles around a point. Now let's move on to vertically opposite angles. So when two straight lines meet at a point, four angles are formed at the point of intersection. Now the angles on the opposite sides of the point of intersection are called vertically opposite angles. So assuming that we have two lines meeting at a point, this is the point of intersection. Let's say the angle here is A, the angle here is B, the angle here is C, and then also we have angle D here. So we are saying that when two straight lines meet at a point, four angles are formed at the point of intersection, and the angles on the opposite sides of the point of intersection are called vertically opposite angles, and they are equal. So angle A is equal to angle B, and angle C is equal to angle D. So we say that angle A and B are vertically opposite angles, and then C and D are also vertically opposite angles. Now to the last one, let's talk about perpendicular lines. two lines are said to be perpendicular if they meet or intersect at right angles. So when two perpendicular lines meet, four right angles are formed. So assuming that we have two perpendicular lines, and this is the point of intersection of these two lines. So we have OA, OB, OC, and then OD. So at the point of intersection, four right angles are formed. So we say that the line AC is perpendicular to the line BD, and the angles AOB, BOC, COD, and AOD are equal to 90 degrees.